Okay, I want to talk about something right here. All eyes on the board. When something is with respect to x, that means all of my equation has x, which also means my lower bound and upper bound is also from the x-axis. And then when something is with respect to y, our equation is everything in terms of y, and our lower bound and upper bound is from the y-axis. Everyone good with that? Just a reminder. So then, let's go on to number 3. On number 3, let's start by graphing this. And when I'm graphing this, it's not going to be perfect. And also, we're going to use a calculator because last time our intersection was a clean point. Today, it's not going to be a clean point. So go ahead and get a class set if you need. Get your own out if you need as well. And I want to go ahead and graph the first one and the second one, so we have an approximation. I'm graphing both. 3. Okay, let's start by graphing the y-intercept of the linear function. On my linear function, the y-intercept is 3. Plot it, everybody. Plot the 3. And what I have on my calc is both the functions on y1 and 2. You can do one at a time, but at some point I want to intersect it. There we go, if you're looking at my screen. Okay, when you're ready with y1 and 2, let's go to zoom 6. And I'm only going to approximate what it kind of looks like. And it might not look perfect, and that's perfectly fine. So it's going to be a little bit past the 1. I think it's about somewhere over here, the intersection. So I know the graph over here, bless you, is doing something like this. And I'm only sketching, so it's not going to look perfect. And then the other side is about that many here. Is doing something like this. And then for the y equals negative 1/2 x plus 3, we know the slope is down 1 over 2, down 1 over 2, and up 1 over 2, and up 1 over 2. And it's okay if it's not straight. And I want to focus on one thing. And actually, before I focus on one thing, let's go ahead and graph or shade in our figures. So to find the shaded region, I can either look at the left or the right, and I'm just going to find one of them, and at the end multiply it by 2. You guys okay with that? Because I have 2 equal pieces. And I know my figure is not perfect, but if you were to look at the calculator, it's pretty obvious we have 2 equal pieces. So we have upper one in blue, whatever color you've assigned, lower one in pink. And the main thing I need to look for is the following. We know that point is 0 on the x. Is there a way to figure out what that decimal value is? Not with our naked eye, right? But we can intersect it. Second calc 5. I'm going to hover pretty close to that intersection. And let's press enter 3 times. And that point is about 2.121. Now you can store this as whatever number you want. But here's the beauty of it. Did everyone calculate the intersection? Because if you don't, and when you recall it, it's not going to know what number. Okay, second calc, 5. And go to the right until you get to the third intersection. And enter 3 times. And it has to say x equals something. If it doesn't, when we do want to use that decimal value, it's not going to know what it is. All right, so at this point, let's write out our integral. We have 2 equal pieces that I'm going to take outside of the integral. And we're looking at it from, let's put a dot somewhere. Put a dot on the top and the bottom, wherever you want. And make yourself a rectangle, skinny, wide, however you want. So we know, looking at this, my top equation is -1/2 x plus 3 minus the bottom equation is our curve, x cubed minus 5x plus 3, of course, dx. And we're going to actually integrate from 0 to whatever that decimal is, 0 to about 2.121. And what, as a reminder, why are we multiplying by 2 at the very beginning? There's 2 equal pieces, okay? Otherwise, you would have to integrate in between, and that's just too much. So let's go to our home screen. When I go to Math 9, I know I'm going to go from 0, and I'm going to type in the x, because the last x that was computed was this decimal. It's going to remember, okay? Then I have my function. I'm going to put 0.5. It's a clean number, so why not? Minus the parentheses is going to be our key, because we tend to forget it. And dx. When I press enter, it's not going to be the final answer because I forgot to put 2 at the very beginning. So hopefully you have 2 at the beginning. I don't, so I'm going to multiply by 2. And if I want to make this into a fraction, that's perfectly fine, either or. In the end, I have a clean number. So I'm okay with the decimal or the fractional value. Do we all make the skinny rectangle? That's going to kind of carry on to 7.2. Yes, ma'am?
What intersection are you looking for?
Between 0 to 2 point whatever that number is.
Okay, so the first curve is like that you're doing.
Yeah.
Mm-hmm.
And you have to compute the x equals on the intersection on the graph, otherwise it's not going to know what the x is. It only remembers the last x that you saw for. And who knows who was using that calculator, right? Yes, sir?
You got 2.121.
Okay, so when I graphed, I went to second calc, 5, hover to that intersection that I want, and you press enter once, twice, and the third. And it'll give you x equals. And you want to see that, because if you don't, and you put in x, it has no idea what number is stored. Okay? All right, now let's go on to number 8. Number 8 and 9 is part of your homework. And I forgot to write on this one. This is with respect to x. Karis is ready to go on Google Classroom when you're ready, okay? All right, on number 8. Where did my number 8? Oh, there you go. Because when you guys see trig functions, you go, I don't remember much of it. I feel like I need to go over them. So let's go ahead and graph this first. And when graphing this, I want to start off by graphing the vertical line at pi over 2. And we can also graph x equals 0. Make sure we're all graphing. And then I want to graph e to the x. We know e is 2.71. So if I plug in some number, and I think we can start with the y-intercept. Y'all remember e to the x has 0, 1, because e to the power of 0 is 1. Yes? Mm-hmm. So then if I type in e to the power of some number over here, so I have e to the power of, I want to look at pi over 2, since that's my bound. It's going to give you a little bit over 4, a little less than 5. So maybe right here. We have an exponential function, so I want to make a curve going up. And then our sign is the one that we need a reminder of, because it's been a while. So let's write on here. Here I have 0 pi. So 0 pi, pi over 2, and 1 pi. And in the quadrantals, we have the first order pair at 0 pi is 1, 0. What's the order pair at pi over 2? 0, 1. What about at pi? If we go to the left, it should be -1, 0. And sine is a function of the y's. So I just want the y's. So that means at 0 pi, we have 0. At pi over 2, we have 1. And at 1 pi, we have 0. And here's our sine curve at that specific domain. And yes, it'll go on forever and probably at some point come up. But that's all I care for. So let's trade in the bounds. And it looks like I can go ahead and highlight my upper and then my lower with the colors that I've assigned. So is this going to be with respect to x or with respect to the y? With the x. If I highlight top and the bottom, it's always the opposite. If I highlight left and the right, it's going to be with respect to y. Cody, what's up?
Where did you get that second point?
Second point, this point?
The blue shaded one?
This point right here?
Yeah.
I typed in e to the power of pi over 2.
Okay.
So then, let's go ahead and make our integral. Go ahead and put a dot on the top anywhere and directly below and create yourself a rectangle. So my top one was my blue function, which is from e to the x, minus my pink function is from sine. So we have sine of x dx. And we know our x values we're calculating is from 0 to what? Pi over 2. And let's go ahead and type this in on the calculator. And let's see what we get as the area within that bound. And I hope you're practicing with the calculator. Because when you get to it on the test day, and you're like, hey, where's this button? That's going to be not good. So we have e to the x. Ask your neighbor, please. And if you want to approximate the area and maybe kind of see the comparison, that's fine, but might be kind of redundant. How many is our decimal to 3 decimal places? 3.789. I have something else. I might be wrong.
That's what I got too.
Did anyone get 2.810?
That's what I got.
Okay, so let's see what I did.
It's like this to this. Oh,
It's supposed to be 2.810.
I got what you got.
Yeah, I think what's happening is it's taking the x value that we computed previously, right?
Oh, and
Yeah, so let me think about it. Maybe if I let x equal to x, but it'll still remember that number. Okay, let's go ahead and do 2 plus 712.
Can't you just clear everything?
Yeah, I just did. Okay, let's try it again.
But should I just put the bounds in anyway? Because that's what you're saying is next.
Right. Let me try this. I'm just clearing everything. That's a little awkward. E to the power of x. And then we have minus sine of x.
So do we have to factory reset our calculator every time?
Sounds like we need to, if the numbers are stored. All right, so let me go ahead and re-explain what happened. If you have 3 point whatever, it had the x saved and it was plugging it in for us. So it looks like if you reset it with 7 plus 712, might be a good idea.
The point of the bound. How do you reset it?
There's a little button on the back.
It's second
There's also a little button on the back.
plus 712.
You poke it with your pencil.
There we go.
I don't know, that's a little awkward. It's kind of annoying. Let me look into that.
There's a button on the back.
There's a button on the back?
Yeah, right there. It says reset.
Okay.
She got it like.
All right. Let's go on to number 9. Okay, number 9 has cosine this time. Okay, what was number 8 with respect to?
X.
To the x.
Just set X value.
Cody, did that work out? X equal to 0?
Wait. I'm not sure. 'Cause then if X
Tell me your way if you have a way. Okay, let's move on to number 9 real quick. Our vertical lines are at x equals negative pi over 4. And then we have pi over 4. Oops. And then I have our cosines. Do we need a reminder on the cosines? All right. So on our cosine, we have 0 pi, pi over 2, and 1 pi. And then the order pair is the same as the one that we did on number 8. But this time, cosine is x or y value? X. So we're just going to kind of use the x value and graph it. So when I do, I get at 0 pi, let's write in 0 pi in here. We have 1. And then at pi over 2, we have 0. And do I have the other piece? Oh, I guess we have to kind of stop at negative pi over 2, which is basically symmetrical. So let's make our graph. And then for the secant, it's going to involve some work. I want to figure out where is my secant at 1 and pi over 4. Let's start with the pi over 4. Secant squared of pi over 4. Y'all remember the ratio of the secant? Hypotenuse over? Thank you, adjacent. And we know pi over 4 is 45, 45, 90, which is 1, 1 root 2. The hypotenuse of this triangle is radical 2. The adjacent is 1. And when I square the whole thing, because it is squared, that's going to give me what? 2. So at pi over 4 is going to go to 2. And we know it's symmetrical on the other side. And would you guys trust the fact that it's also going to go to 1? Kind of go with it? Should I go over that part? Or good? It's good? All right. Let's go ahead and make our secant squared of x. And shade in the areas bounded by it. It looks like this could be like a piggyback of the question number 3, possibly. 2 equal pieces. So let's go ahead and make our upper bound with blue and lower bound in pink for me. And because I don't want to write 2 different integration, let's write out 2 outside. Put a dot somewhere on the top of the blue, directly below, and then make a rectangle. So my top one is a secant squared of x. The bottom one is cosine of x, dx. And if I look at the numbers, we're going from 0 pi to pi over 4. 0 to pi over 4. But there's a problem. On our calculator, do we have the reciprocal trigs on there? No. So the only thing we have to modify is this guy right here. What you're actually going to type instead is 1 over cosine squared of x, since they are reciprocals of each other and they are equivalent to each other. Let's type that in together. And I'm going to remember 2 this time. Math 9, 0 to pi over 2. Then I have alpha y equals 1 over cosine x squared minus cosine of x. Hopefully this one works out. Ooh, I found my mistake. Did y'all see my upper bound is not pi over 2? Oh, goodness. I know. Okay, if you have it typed in, go ahead and press enter. It should be less than a whole. Is that true? Oh, no. So we have 0.586